This is a slope practice for 4-1 for 7th grade. On number 1, it says graph the data, then determine the slope and explain what the slope represents. So whenever you see these, if you get a table and you get a graph, sometimes the easiest way to start out is just to go ahead and plot the points. So over here on the side, they have 1 hour is $11. So I'm going to come over here and plot 1 hour at $11. So they see 1 hour for $11. And then 2 hours will be $22, 3 hours will be $33, and 4 hours will be $44. Once you've got that, that's more than enough to go ahead and plot a line. You really only need 2 dots for it, but I want to try to put all the points on there just to be on the safe side. Now, for finding slope, you've got multiple options for doing this. You can either check your rise over your run, you can divide each one and see if you get the same number, or what I'm going to do is I've been really consistent about using the change of y over the change of x, and so I'm just going to keep using that because this, like I've said from the beginning, will always work for us. So here's our change of y right here. We changed by 11. Here we changed by 1. So our slope is 11 over 1, which there's nothing wrong with that, but I want to simplify it to just 11. So our slope is 11, and because we are doing change of y over the change of x, we are going to be talking about dollars per hour. On to number 2. Same thing, I've already got a table, so I'm going to go and start graphing points. So it says 70 degrees for 24 people. So I'm going to come over here to 70 degrees. I wish we quit zooming out like that. Here's 70 degrees here. So I'm going to go up to around 24. I'm going to have to estimate it just a little bit. Next is 78 degrees for 40 people. So I found 78 degrees, and then there's 40 people. 86 degrees with 56 people. So 86 and 56. Again, I have to estimate it a little bit. And 94 for 72 people. So right around in there. What's kind of unique about this graph is whenever we plot the points, if I draw my line through it, it's not actually going to go through 0, 0, which will matter later on. But for right now, this is just kind of a rough estimate. So for our slope, again, I'm going to do the same thing that we have been doing. I'm going to look at the change of y over the change of x. So from 40 to 56, we change by 16. And then from 78 to 86, we change by 8. So my change of y was 16. My change of x was 8. And this simplifies to just 2. So my slope is going to be 2. Again, because we are doing the change of y over the change of x, we are going to be talking about people per degree. And if I can make this darn thing work again, there we go, people. And per degree. On to number 3. This is Latanya swims 50 meters in half a minute. So I'm going to go ahead and graph that 1 point. I know that we're talking about, actually, I'm going to go ahead and go slope represents because it says this is meters in or per minute. So we are talking about meters per minute. So I'm going to go ahead and graph the 50 meters in half of a minute. So my boxes are counting by halves. So here at 1/2, here's my 50 meters. If I can go 50 meters in half of a minute, I can double both of those. So in a full minute, I would expect to go 100 meters per minute. This is going to be the easiest one to read. If I'm looking at my change of y and my change of x, I know that I'm doing 100 meters per minute. So instead of 100 meters per minute, if I had 2 minutes, it would be 200 meters. Let me change colors there, or change pens there. 300 meters would be 3 minutes, 3 minutes it would be 300 meters, and 4 minutes would be 400 meters. So now I've got a perfectly good set of dots, and I can draw my line through it. Hopefully your lines look better than mine. So because we had that, what I marked right here, the 100 meters in 1 minute, my slope is 100 meters in 1 minute, or just 100 meters per minute. So this simplifies to just 100. Now for the back side. On this one, I've already got my points and stuff, so I'm going to look at 30 envelopes stuffed in 5 minutes. So over here, I'm going to put my dot at 5 minutes and 30 envelopes. We have 60 envelopes in 10 minutes. So dot at 60. I also have 15 in 90. And one more, 20 in 120. So I've got all my dots. I can draw my line through it now. And so now I'm going to do what I've been doing. I'm going to do my change of y over my change of x. So I'm going to come right down here. I'm going to look at this. My change of y, I don't know why I keep switching to the highlighter. My y is changed by 30. My x is changed by 5. So my change of y, I'm going to write this down because I don't think I did it on the last one, over change of x is what we want to know. So the y changed by 30, and the x changed by 5. 30 divided by 5 is just 6. So our slope is 6. So we're talking about 6 envelopes stuffed per minute. So it's envelopes. Some people are simplifying it to ES, but I'm going to go with envelopes. And then per minute. If you put envelopes per time, I would count it correct, but it really doesn't need to specify per minute, because if you say time, you don't know if you're talking about hours, yards, millennia, or whatever else. I said yards. I'm not sure why I said yards. Oh, because I was looking at the next problem. All right, on to number 5. It says there are 3 feet for every yard. Well, honestly, that is our slope. It says 3 feet for every or per yard. I'm trying to get the right color here. So I'm going to go ahead and say that's my represents. So that's my feet per yard. And honestly, because it's for every 1 yard, my slope is just going to be that 3. There's nothing too fancy to do with that, but now we got to graph it. So over here, if we've got 3 feet for every 1 yard, well, here's 1 yard here. There's 3 feet. And if I double the number of yards, I should double the number of feet. So for 2 yards, I should have 6 feet. And so pretty much I'm multiplying by 3 every time, because 1 times 3 gave me 3. 3 times 2 gave me 6. 3 times 3 will give me 9. 3 times 4 will give me 12. 3 times this 5 will give me 15. And it looks like we're just kind of follow that pattern the whole way. So now I can just graph my line through it. And that's it on that one. All right, on number 6, it says use the graph that shows the number of laps completed over time. Determine the slope of the line. Well, I'm going to go ahead and look at my y's and my x's. So here's my y's, here are my x's. I'm going to go ahead and get what the slope represents. Looks like we're talking about number of laps in however many minutes. So we're talking about number of laps per minute. So my slope represents laps per minute. So I really just want to know how many for 1 minute. Unfortunately, I can't really see 1 minute here. So I'm going to do change of y over change of x. I'm going to pick 2 points. Any 2 points will do. I'm going to use that one and that one, because the closer they are, typically the easier it is to read. And there are other ways to do this one. Some of you guys are familiar with it, but I'm going to do it this way for now. So my change of y from 5 to 10, we've changed by 5. My change of x, we're changing from 10 over to 20. I'm going to do that with a highlighter. So from 10 to 20, we change by 10. So again, my change of y over my change of x. We just said y changed by 5 and x changed by 10, which simplifies to 1/2. So my slope is going to be 1/2, which means that we are going to do 1/2 of a lap every minute. The final on the bonus, it says which line is steepest. Explain using slopes of lines L, M, and N. So we got 3 lines here. Pretty much you're trying to see which, like if you were to take a Hot Wheels car and roll it down one of these, which one is it going to go down the fastest. I took a little more time on this in class, but I'm going to try to get through this so we can get this video up for you. So here's how I'm going to go about this. I've got L, M, and N listed here. We're going to look at change of y over change of x for each one of them. We'll do line L first. So I've got 2 dots on line L. There we go. I've got this one here, and I've got this one here. My rise from dot to dot is 1, and my run from dot to dot is 2. So my slope here is just going to be 1/2. Now I'm going to erase this and move on to the next one, just so don't get anything confused. On line M, we've got a dot there, we've got a dot there. So on this one, my rise, I've got to rise 1, 2, 3, 4, 5, 6. And I have to run 2. And then 6 divided by 2 is 3. Erase this again, do the final one for line N. So my change of white, so right before my dots for N, here's a dot here, here's a dot here. So my rise, we got to go down 1, 2, 3, 4, 5, 6. So it went down 6. It's technically negative, but we're really just looking for which one's steepest. So in this one particular case, the negative won't necessarily matter. We go over 1, 2, 3. So 6 divided by 3 is going to be -2. So out of all these, the highest number, I know we've got a negative there, but I'm not really worried about the negative in this case. The highest number that we've got is M, meaning that M has the steepest slope out of all of those. You put a Hot Wheels car on it, it's going to go the fastest.